Everyone. Thanks for joining today's webinar. I'm Supriya Deshpande. I'll be hosting this webinar. And Mr. Rasesh Pallav, our presenter, he's a senior technical consultant at SteepGraph System, and he will be presenting the webinar this afternoon. Here is a quick agenda of webcast. We'll begin with a brief introduction of SteepGraph, who we are and how we help customer with solutions across the product life cycle. Then we will go into presentation round of design collaboration workflow with multi-CAD capabilities of PTC Creo, along with the live demo and wrap up with Q&A at the end. You all are currently in a listen only mode right now. You can write in questions and we will make sure we'll do answer all your questions at the end of this session. SteepGraph has a rich manufacturing legacy tracing back to 12 years of serving all sizes of business, ranging from small, mid-sized manufacturers. We do provide solutions to all group of customers across the globe. We also provide expert consulting and PLM. We help customers to achieve their business goal within time and budget. We are a PTC partner for CAD, PLM, augmented reality, and IoT. We do have highly experienced and certified resources on PLM projects. Here are a few names of our customer like Strata, Emerson, Ericsson, Fossil, and many more. After this, we'll go for the poll questioning. So I'll hand over to Rasesh for a poll.
Right. So let's have a quick poll. Kindly submit your responses. It will help us to evaluate the current state and probably tailor our presentation and our offerings for you in near future. We'll wait for just a couple of minutes. Okay, so I have ended the poll. Here are the results. So it's a pretty mix. We can say that 50% of the attendees are using multiple CAD software solutions, as was expected, and there is a mix of responses in CAD software tools used. So some people are using Creo, some people are using CATIA, some people are using some other CAD. All right. So let me begin the technical presentation for the day. So the topic of today's presentation is multi-CAD consolidation and collaboration using PTC Creo, right? So before we deep dive into the pain of deploying multi-CAD software solutions for your product development, we should understand why companies are forced to use multi-CAD software, right? So typically in any organization, there are various stakeholders in product development, right? So it ranges from your engineering, your manufacturing, your quality, service, okay, procurement, and so on and so forth, right? So in the context of engineering department itself, there are various roles that require specific CAD applications. So for example, within engineering, if you take the role of new product development, who is responsible for creating new product concepts, then he will require certain CAD capability that is very good in creating conceptual designs or surface modelings, right? When it comes to detailed design or creating the fit, form, and function of your product, then the CAD tool needs to be very good in capturing the parameters, in capturing the dimensions, in capturing the fits, in capturing the assembly relationships, and so on and so forth, as well as creating 2D drawings, right? Then within the same department, if you take the role of an analyst who is responsible for validating the detailed designs made, so he will work in a dedicated simulation environment that takes input from a CAD designer and will do a lot of simulations, FEA studies, and so on and so forth. Then there are certain roles within the same engineering organization that are required for visualizing the entire digital mockup. For that, you may deploy a whole different set of CAD tool that requires interface with the detailed design team, with the NPD team, as well as with the analyst, right? Plus, if you go to downstream users beyond engineering department, you have manufacturing, you have quality. They work with a whole new set of applications like CAM, which take input from your CAD models and convert those geometrical inputs to NC programs utilizing CAM capabilities. So as part of fulfilling those specific roles of various stakeholders, which can be internal and external within your company, organizations are forced to use multiple CAD applications. Okay, so that's not an issue. We are fine with companies deploying multi-CAD software, right? It is a necessity, but the pain becomes when, as part of having this scenario, end users or specific roles are facing challenges in processing that multi-CAD workflow to suit their responsibilities and streamline collaboration as well as consolidation, right? So when we say collaboration, any CAD tool should be able to streamline design reviews by quickly toggling through design checkpoints and have the capability to implement incremental changes or simply share the entire CAD workflow with extended teams. And when we say consolidation, we mean that any CAD system that is part of a multi-CAD workflow should be able to improve quality, speed time to market, and lower costs for both engineering and IT. In absence of having this collaboration and consolidation capabilities, end users invariably face the challenges that are listed here. They are unable to directly open and work with non-native CAD data. They struggle and to collaborate and share multi-CAD data with design partners. There is over-reliance on multiple CAD tools to collaborate and work with that data. There is a lot of lost engineering effort moving data and switching between different CAD tools. So there is a lot of effort spent on CAD translation and data translation to achieve the deliverable, as well as there is a wasted engineering time recreating geometry to implement late-stage changes. So as a result, there is inability to reuse and repurpose legacy and non-legacy CAD data. So since we are talking in context of PTC, we say that it is non-PTC data. Right. So this pain of multi-CAD workflows has been quantified as per our own research as well as PTC's research. It has been found that 59% of engineers, due to collaborative workflows, are wanting to streamline design reviews as well as quickly toggle through those design checkpoints, while 35% of the engineers spend time on consolidating their CAD data to suit and to extract deliverables out of that workflow, right? So there is a lot of pain, and there are metrics to quantify this. Okay, so PTC Creo, why we say that it is uniquely positioned to handle this conundrum of collaboration and consolidation is it has got certain capabilities that we are going to show that are well suited for handling this multi-CAD workflow, right? So some of these capabilities that we are going to highlight are Unite technology, flexible modeling, okay, import data doctor and reverse engineering are also part of that capability, but we are going to focus more on Unite technology and flexible modeling, and we can have some sort of overview of the import data doctor process as well as the reverse engineering process. So the focus of this presentation is going to be both from technical presentation as well as from live demo perspective is going to be Unite technology and flexible modeling. So what is this Unite technology? So basically Unite technology is an integrated design technology that enables you to consolidate the non-Creo 3D design data of CATIA, SolidWorks, NX, and Autodesk Inventor parts and assemblies in Creo. So as a result of having Unite technology within Creo, you can work in a multi-CAD environment and collaborate across CAD systems and file formats, even while you build and maintain design intent in Creo across formats. So it allows you, this technology allows you to directly use CAD data from a variety of systems in Creo applications, such as Creo Parametric, Simulate, Creo Elements Direct, Creo Direct, as well as Creo Options Modeler. You can adopt the direct open, you can convert on demand the third-party CAD data, as well as update workflows for third-party CAD data, including the likes of Inventor, CATIA, Creo Elements Direct, NX, and SolidWorks. So as a result of this Unite technology, you are able to minimize the time and effort spent in geometry repair and model recreation. You are able to assemble the non-Creo part and assembly models to create multi-CAD assemblies in Creo. You can preserve the configurations and model structure representations of the non-Creo CAD models. You will be able to open non-Creo part and assembly files and other software that are integrated with Creo. And you can continue to use the source CAD systems as a design tools of the non-Creo models. So there are many benefits of this Unite technology that help prevent high cost to support 100% upfront data conversion. So this slide explains what is possible from perspective of certain end user operations in terms of importing, opening, updating, and save as third-party CAD software. So the important thing to note is Creo Design Essentials, the base package itself supports importing, opening, as well as updating of both SolidWorks as well as Autodesk Inventor files, which are mostly the third-party CAD software tools apart from Creo that are being used in the industry. Plus, through some certain extensions, Creo can also support updating of CATIA V5, Siemens NX, as well as Solid Edge data. So the capabilities are quite comprehensive in terms of industry standards supported for importing, opening, updating, and saving as file formats of other third-party CAD applications. The next thing that we want to talk about, apart from Unite technology that aids collaboration and consolidation within PTC Creo, is flexible modeling. So flexible modeling is quite a unique capability within Creo. It was introduced, I believe, with Creo Parametric 1.0 or 2.0. But this capability, which is available in every seat of Creo Parametric, it allows the end user to easily make edits to both native Creo geometry as well as non-native Creo designs, thus enabling you to quickly and easily make late-stage design changes. So this capability is nothing but based upon intelligent selection of geometry within the design. There is advanced capability for rules-based search and selection, as well as for feature recognitions of regular engineering features like rounds, chamfers, and patterns. Plus, flexible modeling also now has the ability to recognize sheet metal features on imported geometry. So all you have to do is to, once you import a model which you think is a sheet metal feature, all you have to do is to convert it using conversion options of Creo, and then you can recognize the sheet metal features, and then you'll be able to edit the bends and pull the walls using flexible modeling, right? So we are going to spend a lot of time in the live demonstration on both Unite technology as well as flexible modeling. Okay, so then there is import data doctor. So import data doctor is task based. It allows you to repair imported geometry that typically you get files like step and IGS and Parasolid files. Those files end up as surface models, and as you know, surface models are not the highest model quality that you need to have for creating downstream deliverables. You need to have solid models. So import data doctor has got automated and manual workflows for repairing the surface models that invariably come as part of the import process and help you to convert them to solid model geometry. But this IDD is not some sort of a magic wand. It is dependent on the quality of the imported data. So if the imported data is bad in terms of its very nature, the authoring system or the user that has created it has not modeled it properly, then there is no magic wand within import data doctor to automate and repair that bad design. So if there are any gaps, any slivers, any non-parameterized surface issues, then IDD has got the capability to fix those issues. Okay, so it is a simple case of the input, the quality of input is equal to the quality of the output, right? And so is the case of Restyle module. So there is a module for reverse engineering in Creo, and that capability is through a feature called Restyle. So reverse engineering is also an important collaborative and consolidative effort within the product development process, because invariably as part of any reverse engineering effort, you deal with point clouds, you deal with facets, and you require some specialized reverse engineering application. So if your CAD tool can have this capability, then it adds value to your capability as a reliable engineering service provider. So as part of this Restyle capability, you will be able to manipulate and edit point cloud data. You will be able to convert it into wrap phase and facet phase, edit the wraps and the facets, as well as there are automated and manual workflows to convert this into a surface and or a solid model. And once you have a solid model, you will be able to utilize it for downstream operations like manufacturing, 3D printing, and so on and so forth. Okay, so we will see, we will try to see this Restyle also in action. Okay, so with this, I will switch to the live presentation of the software, and then we'll come back to the PPT. Is everybody able to see my Creo screen?
Yes, Rashesh.
Great. So first we are going to showcase the Unite technology. So if you remember, Unite technology has the ability to import non-native Creo formats like Inventor assembly or Inventor parts, or even NX assembly parts, CATIA parts, you name it. So as part of this Unite technology demo, what I'm going to do is I'm going to assemble a SolidWorks assembly into this Creo assembly, right? Then I'm going to assemble a native Creo sheet metal part on top of that SolidWorks assembly, right? So that will be the first piece of the demo, and then I'm going to change the SolidWorks designs, and we will see how Creo can handle that change. All right, so this is the objective of the Unite technology of seamlessly managing change on a third-party CAD data within Creo parametric. Right. So let me begin. I will switch to a particular assembling view, and I'll go for the assemble from the component tag group. And if you see, I can assemble Creo files. That is the obvious choice since we are in Creo parametric. But you can see that Creo supports a lot of third-party file formats. So you can see that it supports CATIA v5, SolidWorks, okay, NX. Co-create is Creo Elements Direct, the earlier version. Then there is Inventor Parts and Assemblies, Creo View. Then it also supports industry standard neutral file formats like IGS, VDA, DXF, neutral, and certain point cloud formats as well. So there is a lot of choice in what you can open and import within the Creo assembly environment from third-party file formats. Right. So, suppose you are a conceptual designer, then you can even import, say, files from NURBS-based surface modeling applications like Rhino. And suppose if you want to import it from any additive manufacturing standard, then there is 3MF as well. So the list is pretty comprehensive and supports all industry standards. So in this case, I'm going to open the SolidWorks assembly. So here is my SolidWorks assembly. I'm going to open it. And for placing it, I will simply right click and go for the default constraint. So now that SolidWorks assembly is in place, and I will complete the operation. Now, as part of the first phase of the workflow, I will assemble a Creo sheet metal model on top of this battery assembly, which has been made in SolidWorks. So I'll again go for assemble. I'll search for that sheet metal design. Hit open. And for assembling it in place, I will utilize coordinate systems. So I'll go for selecting the part level coordinate system and assemble it to the master assembly global coordinate system. And now it is in place. But if you look closely, as part of the assembling exercise on the Creo sheet metal component, there is a certain interference between that component and the SolidWorks battery assembly, right? So I need to remove this interference. Okay. So what I'll do is I will activate this particular sheet metal component. And I want to take the reference of the SolidWorks assembly for implementing that change of removing that interference. Okay. So I will go for a certain feature called copy geometry for taking the reference. I will take the reference of this back surface of the SolidWorks model, right? And I want to have Creo send me a notification once, in case in future that reference changes. So I'll go for manual update and provide notification. I will hit OK. Right? So once that is done, what I can do is I can switch to a flexible modeling capability. And I will move this particular reference to nullify the interference. Okay, so what I'll do is I will select the geometry. I have intelligent selection filters. So I will select that. And then I will again go for control and I will select same. So now I have selected the geometry. I will go for the move operation. So you can go for a simple move, you can go for move by dimension, but in this case, I'll go for move using constraints because I want to capture the distance. So I'll go for move using constraints. I'll go to the placement tab. I will say that the constraint type is distance. The moving geometry is the sheet metal reference, while the fixed geometry is the copied reference from the SolidWorks model. So we now got the distance. I'll make the distance as 8 and hit OK. So now you see there is a clear gap between the SolidWorks assembly and our sheet metal cover. Okay, I want to add one more sheet metal feature on top of this battery model, utilizing the reference of the boss on the top. Okay, so again, I'll go to the copy geometry feature. I will say that this is going to be my reference. And if the reference changes in future, I want Creo to give me a notification. Right? So once that is done, what I can do is I can go to the sheet metal geometry, go for the sketched form functionality. So I want a certain feature that will be used to lift this cover in case of any sort of servicing or any maintenance activity, right? So that's why I require this sketch form. So I will simply select the sketching plane for the same, right? Now I'm in the sketcher mode. I will go for utilizing that extruded boss reference on top of the SolidWorks model, right? And then I will manipulate the sketch form capability to give me the desired geometry. Right? So this is what I wanted. I am happy with what I've got as of now and done. So this is the first part of the workflow, right? I will activate the entire master assembly. I can hide the relevant copy geometries. I can go to the layer tree and save the status. And then I will save the model and close it. Okay. Now what I'll do, I will, as part of the workflow, I came to know that there is going to be a change. Okay. So I am changing the battery model has got changed. I will implement the change by simply copying and pasting it in the actual directory. So this is a crude way of doing things. For changes like this, it is recommended that you have a PDM system. But for the simplicity of the demonstration, we are replacing the files in the original folder. So once that is done, I will again go to Creo and I will open the same model, the same assembly, right? So this time, when you open the model, right? So let me open the model. Right. So as you see now, you have opened the model and the original SolidWorks model has changed, right? So you get a notification from Creo that the model in the assembly is outdated. You need to change that or you need to update that. So what I can do is I can go to the relevant model tree feature. You can see that this copy geometry is outdated. We can go for evaluating that update. So as part of that update process, we can go for showing the difference. So you can see, you can isolate what has changed. So you can clearly see what was changed, what has been outdated. You can even isolate what is outdated, okay, what is changed, right? And ultimately you can implement the update. Okay, now you see that the form feature is outdated. Okay, so again, you can go to the relevant copy geometry, right click, update control, then go for show difference, then go for isolate, right? And again, the same thing, you can see what is outdated, what is changed, right? And ultimately you can implement the change. There you go. So now the change has been completely propagated. right? So this is the power of the Unite technology. It allows you to seamlessly manage the changes made in third-party CAD software, allows you to update the third-party CAD software within the object modeling environment of Creo itself, right? So this really helps you to collaborate with any stakeholders within your product development process that are using third-party CAD tools. Your CAD workflow will not be hampered because of somebody using a CAD tool of not your choice. Okay, so Creo offers that flexibility to you, offers that capability to you to collaborate with any stakeholder within your company or outside your company, irrespective of the CAD tool they use. So that is the power of this application. Okay, so this was Unite technology. I want to deep dive more on flexible modeling. Okay, so let me close this guy. Okay, so as you can see in this model, again, it's an imported feature. So in the feature tree, there is nothing. Okay, but still, as a designer, you would like to make changes on your design, irrespective of whether the design intent is presented to you or not. Okay, so that's the challenge. So suppose you have been you are an analyst as well, and as part of that analysis, you are required to de-feature that model or this model, right? So you don't want this round to be considered for analysis. Okay, so I can go to the flexible modeling capability. Okay, and flexible modeling is rule-based geometry selection. Okay, so I can select just one part of this round, and I can go for selecting the entire round feature, and then I have the option of removing this entire round geometry selection set. Okay, so I just click on remove and hit OK, and that's it. So that round is gone. So no need to worry whether what that round does, how that round was modeled in the first place. If you want to delete it, okay, you should have the capability to delete it and not impact the integrity of the design, right? So again, as an analyst, you want this round to be present, but this round to be modified in terms of its analytical value. So again, I will select the round. I'll go for the selection filter, and then I'll say I want to edit this particular round. Okay, so the current round is of value 1. I'll make it as 1.25, and that's it. So simple. Okay, so the CAD tool should not hamper your removing ability, your ability to manipulate or modify the value of any features. Okay, so that is what flexible modeling gives you. It gives you the power to make changes irrespective of whether that design intent is captured or not, and thereby you have the power to manipulate the design intent the way you want it. Okay, so one more example I want to show is this 4 holes here. They are clearly part of a pattern. Okay, but since this is an imported geometry, there is no way you can manipulate the placement of one hole, and all the other 3 holes should also follow that modified placement unless you recognize it as a pattern. Okay, so what I'll do, I'll first select the pattern leader. So as per my judgment, this particular feature is going to be the pattern leader. So I'll simply select one half of that surface. Again, there are rule-based selection shortcuts. So I'll go for selecting it as a cut. So it captures the entire feature. And then I can go for recognizing it as a pattern. So it has recognized it as a pattern. That is good. But again, I want my CAD software to give me the option of editing that pattern. So if you go to options, there is clearly allow edit that you can do. So it now shows that the linear distance in this direction is the displacement is 20, while in the vertical direction it is around 37. So I'm happy with the 20 value. I will modify this one as say 35, and that's it. So now it has the pattern parameters of your choice. But now, suppose if I modify this pattern leader, will the other pattern instances, because of the pattern recognition, also move? For sure, what we can do is, again, I will go for the same intelligent selection technique. I'll go for selecting the entire feature. I can go for the move option. This time, for the simplicity of demonstration, I'll go for move using dragger, but you can go for move by dimension and move using constraints as per your required design intent. So I'll go for move using dragger. I'll move it. That's fine. This move is fine, but it should impact the pattern also, right? So if you again go to options, I simply have to recognize that earlier pattern recognition feature. So I'll simply select it, and there you go. The other pattern instances also move in unison according to the pattern leader movement that was executed as part of this move feature. Right? So some critical late stage design changes have been done on this model. Lastly, if as part of the analysis, you come to know that the angle of this particular section here should be changed from its current value. Okay, so you can do a lot of such kind of changes without, again, I'm stressing on the point, worrying about the design intent. So I will select this face. I will select a particular view. Then I can go for intelligent window selection, right? And then I'll again go for move using constraints this time. So as part of move using constraints, I want to capture that angle because I want to modify that angle. So therefore, I am utilizing that option. So again, I'll go for placement. I will select the constraint type as angle offset. Okay. So the fixed geometry is this flat face because that is from where the angle is measured. And the moving geometries are obviously one, inclined face. It can be this face, it can be this face. I will select this face here. And it shows the angle which has been captured. Instead of 20, my analysis shows that it should be 21.5. There you go. That's it. Okay. So imagine you not having this capability in your CAD application. If you have to do this without flexible modeling capability, I'm not sure any CAD application can do this without certain feature failure or without having that tool set capability given to you. Okay, so this is fairly unique, and it will solve all your challenges from point of view of making late stage design changes to give a consolidative and a collaborative effort in your product development process. So that was flexible modeling in action. And lastly, what I want to show is certain reverse engineering capability. So let me close this. So reverse engineering starts with a point cloud. So let me switch to a particular working directory here. So as told earlier, reverse engineering inputs can be in the form of points. So you can see that there is a IBL and PTS. So these are dedicated for any sort of reverse engineering capability within Creo. So I will switch to the PTS files. So there are a lot of point clouds here. So just for the simplicity of demo, I will select, say, this horse. Okay, so this horse file is nothing but a faceted file. So I'll select facet option. And you can see now this is a horse design, and it is nothing but a collection of points. Okay, so as part of entering into the reverse engineering workflow, you have the capability to edit this point cloud. You can reduce the noise. You can fill holes if you see, if there are any holes within the point clouds. You can fill holes, you can modify the sample according to whether it is a mechanical or an organic design. Okay, so this is clearly an organic design. Yeah, but I'm happy with the point cloud. So I can move to the next phase. So any reverse engineering effort in Creo is in 4 phases. There is a point phase, there is a wrap phase, there is a facet phase, and then ultimately there is a surface modeling phase for which you will enter into the Restyle environment. So I'm happy with the wrap, with the point phase. I will go to the wrap phase. So what will wrap do is it will join the dots and it will create initial triangulated geometry. Okay. So this is the wrap phase, but you can see it has created some unwanted geometry as well. Okay. So now you are in the wrap phase and there are certain wrap editing tools that are presented as part of this. Okay. So you can totally delete or remove these webs, they are called. Okay. So what I can do is I can go for remove webs option. I can say remove web from this point to this point. Yeah. And I can say preview and it's gone. Right. Similarly, you can go for remove web from this point to this point, preview. And there you go. So very quickly, and again, you can do the same thing here. So I will not, reverse engineering is a very time consuming and a very skillful and a very reiterative process. Okay. So once you convert this into a wrap phase, you can move to the next phase and facet phase. Okay. And from the facet phase, you can go into the restyle phase. So reverse engineering is very skillful. It is directly dependent on the quality of the scan and the quality of the point cloud. Okay, and then Creo can convert that point cloud into surface model using automated as well as manual workflows. Right. So if interested, we can have a dedicated session on this restyle capability. So attendees do let us know in your comments or in responses. Supriya will share her email and you can reach out to her if you want dedicated sessions on advanced capabilities of Creo like reverse engineering. But it's a very good capability. It has got a certain learning curve, but definitely it has got fantastic capabilities in reverse engineering. The reverse engineering engine within Creo is nothing but coming from an industry leader in the form of Geomagic. Okay, so it is Geomagic reverse engineering engine in Creo parametric. So you get the best capability from an industry leader as far as reverse engineering is concerned. All right, so I think I'll just wrap it up with a quick conclusion. So basically, you can see that if CAD consolidation and collaboration is a challenge, then Creo has, through the Unite technology and flexible modeling, has got capabilities that can effectively consolidate multiple CAD systems into one unified CAD workflow to improve quality, speed time to market, and lower costs for both engineering and IT, as well as reduce IT supports, maintenance, and training costs. For collaboration, again, Unite technology comes into play because you can collaborate and share multi-CAD data with design partners, and you don't have to rely on multiple CAD authors and tools, thereby increasing engineering productivity and capacity for innovation, as well as reduce engineering time and cost by easily integrating multi-CAD data. So therefore, we are of the firm view that Creo is the future of smart product design because it has got industry-leading capabilities. It has got advanced and cool trending capabilities in the form of product insights and IoT and augmented reality. It can support the latest additive manufacturing workflows and standards, as well as it has got fantastic product manufacturing information capability in the form of model-based definition. So all in all, if you have Creo, you will be able to design smarter. Okay, and the world is full of smart connected products, and that is why we feel that Creo is the right fit for your product development process. So with that, I will have the session open up for any Q&A and a wrap up from Supriya. Thank you.
Thank you so much, Rashesh, for your informative session. You can ping questions in the chat box. So we'll get back to you on the same.
Good evening, Rasesh. Suraj here. We have one question from the attendees.
Okay.
The question is it necessary to perform 100% upfront conversion?
No, it is not necessary to perform 100% upfront conversion. The conversion is basically on demand. So, but only thing you need to take care while converting is, as part of the conversion, it becomes part of the Creo object model. So if you need to manage that data, then it has to be managed within the architecture of the Creo file system, or using any Creo PDM like Winchell. That's the only thing. Other than that, it is not required to convert it 100% upfront. Creo has on-demand conversion. So it will ask you, as part of that workflow, whether you need to convert it or not. It is totally your choice. As part of the workflow, you will never be forced to act in a certain way. Creo is always flexible.
Okay.
Another question is, the native format and the PTC Creo object are both managed within Winchell or user hard drive?
Yeah, it can be managed within Creo file management system. Okay, if it is converted, as well as Winchell. But so we always recommend, if it is a multi-user team, and if the volume of data is such that your IT maintenance is too much in maintaining the data on shared network drives, then we always recommend it to be deployed under the umbrella of PDM. So Winchell PDM link is the perfect solution for managing any Creo object data types.
Okay. Another question from audience: is it automatic updating is possible within base package itself, or do we require some plugins or extensions?
Right. So that's a good question. So it depends upon what third-party CAD data you are importing. So as I said earlier during the presentation also, if you have Autodesk Inventor and SolidWorks designs, and they need to be updated within Creo, then the base package of Creo Design Essentials itself has the capability to do that. Okay, so it has got multi-CAD collaboration module for supporting Autodesk Inventor and SolidWorks from perspective of opening, importing, and updating, right? But if you want to update, say, CATIA V4, V5, or say NX, okay, then you will require separate extensions to go with the base package. So it depends clearly on the third-party CAD tool that you are using and you need to manage in Creo. If it is Autodesk and SolidWorks, no problem, it can be done within the base package. But if it is NX and CATIA, you require certain extensions.
Okay. Thank you, Rasesh, for the answer. And one more question we have, how can we merge meshes of varying accuracy into single instance?
Yeah, so if it is a pure mechanical engineering component, then I believe that is not of a concern, because as part of the import process, you can control the accuracy. Okay, but if it is a huge mesh, and if it is a sort of an architectural project or of that standard, then I believe Creo is not suitable for handling that workflow. If the quality of point cloud is huge to the volume of buildings and plants and factories, then I guess there are dedicated point cloud applications for registering these meshes and aligning them. Okay, but if it is pure mechanical components like pistons and connecting rods and stuff, then the reverse engineering extension within Creo is perfectly capable of manipulating that mesh irrespective of accuracy and converting that mesh into a wrap phase, facet phase, and ultimately converting that to a solid model using Restyle.
Okay, thanks, Rashish.
Any further question from audience?
All right. Thank you so much, guys. Please get in touch with Supriya for any sort of inquiries on Creo or PDM or any sort of PTC software. We'll be happy to assist you, and we look forward to your presence in future webinars. Thank you. Have a great day.
Thanks, Rashish. It was a very nice and more informative session, actually. So it
Thank
will
you.
help us.
Thank you, team.